Now we want to talk about average atomic mass. Now, average atomic mass is referring to the atomic mass that's at the bottom of our periodic table. We know if we look at the bottom number right here that it's referring to the atomic mass. But have you ever wondered how we can have decimal places? We can't have half of a proton or half of a neutron, so how is it possible that we have these decimal places? Why aren't all of our masses whole numbers? And the reason why is that some of our elements, actually a majority of elements, have what we call isotopes. Now, an isotope from our previous video are atoms of the same element that have different number of neutrons. Element with different number of neutrons. Now, if I have a different number of a neutron, that means my mass is going to change. And so when the mass changes, then we have to take an average. But not all of these isotopes are equally abundant. Okay, so for example, if we refer to an isotope as kind of like a brand or type of apple, right? When you go to the grocery store to buy an apple, you have to decide, am I going to buy red apples or green apples or white apple or yellow apples, right? But in certain seasons, red apples might be more abundant than green apples or yellow apples, right? There are more of them. And so your relative abundance, or the percent that it's there, will affect it. It's not an even average, it's a weighted average. Similar to how you would figure out your grade in a class, right? Your homework is weighted differently than a test. We know that tests are worth more. Well, if you have a higher percent, you're going to have your average atomic mass is going to be closer to that grade or that percentage. For example, if we look at what's in this box, okay? It says a sample of cesium is 75% cesium-133, 20% cesium-132, and 5% cesium-134. What is the average atomic mass? Now, as a reminder, this number right here refers to the mass number, or the mass of that particular atom. Now we see that cesium has a mass number of 133, 132, and 134. So it has 3 different isotopes for its element. They're all cesium. They all have the same number of protons, which is 55. They just all have a different mass because they have a different number of neutrons. Now, in order to calculate the average atomic mass, we take its percent to multiply it. And remember, if you're going to use a percent and multiply by a percent, you have to take it out of its percent sign. So you can either move the decimal 2 places to the left, or you can divide by 100. It'll give you the same answer. So we take 0.75 and multiply it by 133, because we know that 75% of all of the cesium in the world is cesium-133. Our next percentage, 0.20, goes with cesium-132. So I say 0.20 times 132 gives me 26.4. 5% of the cesium in the world is cesium-134. So multiply 0.05 times 134 to get 6.7. Now, these answers are each isotope's contribution. So it means this is what the isotope is essentially donating or is in charge of the average atomic mass. So when we add all 3 of them together, we get our total average atomic mass for the element. The mass number, or atomic mass number, for each isotope is different, but the average atomic mass for the element, okay, depends on every isotope that it has. So if we were to look at problem number 1 as our example, we see that we have iodine, because that's the capital I, and 80% of all the iodine in the world is iodine-127, 17% is iodine-126, and 3% is iodine-125. So what we would do is we would convert all our percentages to decimals. So 80% becomes 0.80, 17% becomes 0.17, and 3% becomes 0.03. Remember, we did this by dividing by 100 or moving our decimal 2 places to the left. We're then going to multiply them by the masses that they're associated with. 80% is iodine 127, 17% is iodine 126, and 3% is iodine 125. When we multiply these together, 0.8 times 127 gives us 101.6. 0.17 times 126 gives us 21.42, and 0.03 times 125 gives us 3.75. Now, when I add all of these together, 101.6 plus 21.42 plus 3.75, I get 126.77 AMU. Remember that AMU stands for atomic mass unit. Now, one thing to note is that the number 126.77 is closest to 127, right? If we were to round this up, I would get to 127. But that should come to no shock to us because iodine 127 makes up 80% of it. And that means it's going to be closer to that number. If we had, sorry, my little notations are being weird. If my iodine 126 had a higher percentage, it would be much closer to that. Okay, so whichever element, whichever isotope is a higher percentage, will have the atomic mass unit closest to it.